everybody. Thank you for coming to my session. Thanks for sticking around late in the day. My name's Adam. I'm a senior platform engineer for a large financial services company. And this is my first time presenting here after attending a couple years ago. Before we get started, I did want to set expectations. This is not a technical talk. There won't be any code on screen or anything. It's about reading the tea leaves of how Apple works and makes decisions. Because if we can understand that, it really helps our jobs and our organizations. And so my goal with this session is to help you make great decisions based on where we've been in the past and where we're going. I do have to take a quick break before I get started. Everything in this talk is based on publicly available information only and isn't official guidance or information from Apple. Everything I'm about to talk about is based on my personal insights and past experiences supporting Apple platforms, not my employer's. So Apple, the company, is very much like its own products, just as their products receive constant iterative updates. It's the same way that the company handles a lot of things. Apple is a company of patterns, and there are many relevant patterns for Mac admins for us to talk about today. Apple is a company that's very careful with what it says. We often take this for secrecy, but in many cases it actually provides some clarity because when they say something, we can trust that they mean what they say. If you look at the timing and the decisions and actions behind some of those milestones that Apple has done, we can learn a lot of stuff. And so consider this session kind of a history lesson on what Apple has done and kind of where things are going, the patterns that Apple has established that they do. So welcome to How Apple Rolls. And so whether you're new to the Mac or you've been doing this gig for a while, understanding how Apple iterates and thinks about things helps us, again, like I said, make very informed decisions and help set us on the right path, help maybe convince leadership of certain things that need to be invested in now. And so this talk actually kind of originated from a note that I've had for a while of how to explain or justify different things that were coming up in the Apple ecosystem. And so how Apple rolls doesn't just mean how they develop and iterate and ship products. It also means how Apple sets its priorities. So the number one priority is always Apple, all the time, right? Number two is going to be Apple's users. And then after that, developers. And then we get to us, Mac admins. So Apple's got lots of advocates for us inside. We all know that. We all see the impact that we can have through feedback, for example, through Apple. But lots of decisions always start with Apple and then the considerations for users and developers and then us. That's okay. It's just important context to remember when we see new things coming from Apple. So I wanted to start this off with a good visual example, looking at the development of the Apple logo. Because the original logo of the rainbows, for example, didn't actually start in that order arrangement. And the shape was slightly different for a while, but I'm not able to talk about that because of that earlier disclaimer I mentioned. So instead, we're going to take a quick look at system settings, and actually, I mean system preferences, of course, because Apple's not afraid to make major or minor changes between OS releases. And this is a great visual example to kind of get us thinking about this. So the first public beta of Mac OS X Kodiak is where we started with system preferences in the modern era. And just taking a look at how quickly things change at the start and then settles into something that's pretty recognizable to what we had for basically the whole run until system settings. So next we had OS X Cheetah, Puma. We're starting to see some changes here. Jaguar and Panther. And now we're getting into kind of that middle phase of OS X at this point, which feels further away than it ever did at this point. And you start to see there's fewer changes every year, just maybe a new preference pane somewhere, maybe a new icon. But they've kind of gotten to where they wanted to go, and that's where we're sitting at. And then eventually we get some new user interface stuff that gives it a slight refresh, and Apple shuffles things around to make it hard for us to find things every year. And then we get into the first real redesign that we'd had for quite a long time in macOS Catalina, which stuck around for another year in macOS Big Sur before we got the whole redesign of system settings. And so it's just a fun, I think, a good example of how Apple just kind of hacks away at it for a little bit, makes some big changes, and then they get to where they're going and they're kind of done. And that it comes across for some of the technology and stuff that we use as well. And so the first kind of transition we're going to talk about for the technology transitions are going to be file systems. So this is the start of the company's iterative process, and we can go back to begin in 1985 when Apple introduced the hierarchical file system. HFS was built as a replacement for the Macintosh file system that was introduced just a year and a half before. And HFS was built upon Apple's first operating system with a hierarchical file system, which was originally for the Apple IIe. And files were not referenced by file names anymore. They could be referenced by unique file IDs. And Apple introduced HFS out of necessity because a 20 megabyte hard drive was being released that year. And HFS brought lots of improvements for performance on larger hard drives. So 1985, HFS is introduced. The next time we have a notable change in file systems, though, is 1998, when Apple introduces its replacement of HFS Plus. You may also know HFS Plus as macOS Extended, which was developed under the codename Sequoia, actually, which is kind of fun. HFS Plus supported larger files and a full 32-bit allocation mapping table, double from HFS. And so while HFS Plus became the primary file system in macOS upon its release, the original HFS would continue to see about a decade of support before being deprecated to read-only status, followed by another decade until its eventual removal. So this is a pretty extreme example, measured in decades, obviously, but it kind of perfectly showcases how Apple keeps things moving and has long-term plans in place. And sometimes those plans take decades. So a few years after its introduction, originally introduced as journaling file system for macOS 10 server, we get HFS Plus adding journaling support, or HFS-J. And this improves data reliability. The odds of your files being corrupted is significantly lower as a result, and there's some more performance improvements. A year later, HFS-J becomes the default. So here we start to see a pretty quick trend, or a pretty quick move, rather, and a new trend of iterative development on macOS 10 in these early years. Just a year after being introduced as the default, that short turnaround is something we'll see again in a lot of cases, especially with file systems. And around the same time, HFS Plus gained support for hard links to directories in addition to files. And so one important thing to remember about HFS Plus at the time, it was never designed for Unix-like systems like macOS 10. So features like file permissions and hard links had to be retrofitted. So remember how I just mentioned that HFS Plus gained hard link directory support? There were multiple reasons for this, but the number one reason is Time Machine, because Time Machine was introduced in 2007, a couple years later, and this is a fundamental part of how Time Machine works. In 2009, we get to see the first kind of move to deprecate HFS. So HFS is limited to read-only support. This is often Apple's first method of deprecating something. As in they are introducing a roadblock to use it, to keep using it, make it a little bit more difficult or a little more frustrating to use to help push you to the other newer mechanism they want you to use. Additionally, in 2009, HFS volumes could not be updated or created on the version of OS X then. So in 2011, HFS Plus gains some more new functionality, support for logical volume encryption, forming the foundation of File Vault 2, which we'll come back to in just a moment. But it's just, again, important to see that these moves happen right before Apple is adding some technology. There's a reason they're pushing people to HFS Plus at this point. And then a couple years after being made read-only, HFS standard is no longer supported per Apple's release notes. This is about as clear as it is listed. At the time, HFS continues to work and continued to work in read-only mode for a couple of years. But of course, after a few years, we're now a full decade after read-only status, 20 years after its replacement was introduced. And in macOS Catalina, HFS is finally removed, bringing an end to that transition, which, like I said, is an extreme example lasting 2 decades. But let's take a step back real quick, because we all know something came after HFS Plus, and it's what we're using today. And that started in 2016 when APFS was introduced. At the time, it was clear this would be a replacement for HFS Plus, but we didn't know what the timeline would look like. We did kind of have an idea it probably wouldn't take 13 years, right, for it to become the default or anything. But much like HFS Plus, APFS sought to resolve a lot of shortcomings of its predecessor, largely stemming from, again, the origins before macOS 10. APFS promised performance improvements, just like we usually get with file system upgrades for modern flash storage at the time. That was still kind of not new, but new-ish, right? Apple still had Fusion drives, for example. And then APFS has better support for encryption and snapshots and all that kind of stuff. So when it was introduced in 2016, it was available as a preview via disk utility during the beta period. And then it wouldn't even be a full year later. It would be early in 2017 that APFS was released for iOS devices, in March 2017 actually, as a mid-cycle OS update. So this was a file system migration that users didn't even notice. Happened overnight, silently, to hundreds of millions of devices. It's honestly kind of wild, like engineering that went into that. The process behind it is pretty fascinating if you haven't heard about it before. During multiple updates before this update shipped on iOS, the phone would perform the migration, do some checks for consistency, and then roll itself back to the previous file system. I think 3 or 4 versions before, so they had months of data of this working. So later that same year, macOS also moved to APFS, which is also a surprise. So macOS High Sierra came out, and APFS is suddenly a thing that we're all moved to very quickly. At the time, it's kind of anyone's guess why this is happening so soon, but it's almost like there's some other kind of transition coming later with processors maybe, where Apple might want everything to be on the same file system. One asterisk on this, in 2017, Macs with Fusion drives were not migrated until 2018 because the support for those configurations wasn't built in. So a year later, APFS is standard on all Macs, and documentation at the time was released. We're 10 years out from the previous file system being deprecated. We see a replacement for its replacement. So how long will HFS Plus support remain? It's possible it'll continue to exist for a lot longer than history might suggest, but if it's something you're dependent on, I would try to see if there's a reason or a way to move to APFS for that. There are lots of important security updates that we've been able to get for macOS as a result of APFS, starting in 2019 with system volume groups, with the dedicated system volume being separated from user data. It's something I think we already take for granted a couple years later. And then the pace of security updates made possible by APFS continued with the signed system volume just a year later in macOS Big Sur. And that means that macOS is now signed, sealed, and booted as a snapshot. And that's a big security win that, again, we take for granted already at this point. Also in 2020, Time Machine had worked on APFS drives, which had been a dependency on keeping around HFS Plus. So that was not too long of a time to get past that point, but really we can say 2020 is when Apple has no real use for HFS Plus at this point. And also in 2021, we as Mac admins started to get the benefits of moving to APFS with features like erase all content and settings coming to macOS as well. So that's file systems, but I do want to take a quick detour into something else that's pretty related to it, and that's File Vault. While there wasn't a transition in the same sense, it's another good example of just that constant iteration of core features. So File Vault has its origins in 2003. Starting with the user's home folder, File Vault was introduced in macOS 10 Panther, and this feature used an encrypted sparse disk image, which had some shortcomings obviously from the start. It was effectively a single large file. There's significant performance trade-offs with that. So 2003, File Vault introduced. So it's not a surprise that we got a little under a decade later, File Vault 2 introduced with full disk encryption, eliminating a lot of those performance roadblocks, preventing possible adoption in enterprises, and making it a standard feature that's expected at this point. Apple originally introduced full disk encryption on the iPhone in 2009, so this is an early example of things from the iPhone coming to the Mac. And this full disk encryption was software-based at the time, which obviously is a massive improvement over the original File Vault, but there's still room for more improvements. And in 2017, Apple gets there with hardware-based full disk encryption. So while the iPhone had hardware-based full disk encryption since nearly the beginning, Apple had to bring the T2 chip to the Mac to enable this. So now on Macs in 2007, the data on the internal flash drive is encrypted using a hardware-accelerated AES engine built into the T2 chip, just like on the iPhone. There's actually two processors in the T2 chip, the primary serving as the coprocessor for the Intel processor at the time running Bridge OS, and then there's a second one, this Secure Enclave processor, running its own OS, which generates and stores the encryption keys. So the design of this T2 security chip and its hardware-based encryption could prove to be an indicator of how Apple might architect its own silicon for macOS, should that ever happen. Also in 2007, we got features that are related to FileVault. So we got the secure token. Secure token is a wrapped version of a key encryption key that's created and protected by a user's password, has a lot of ties to FileVault. And this is created during user's creation, which is a new challenge that Mac admins have to deal with. 2 years later, we get the bootstrap token, similar kind of challenges from the Mac admin side of this is an improvement, but it's another process and another thing to understand and see where we're going. But its importance would soon extend beyond FileVault with the introduction of Apple Silicon. And at the same time, Macs with Apple Silicon were introduced in 2020, which brought us volume ownership. And so this is really good for us, but it also, again, caused here's new stuff for us to learn every year about how volume ownership protections can cover things like startup security policy, authorizing software updates, erase all contents and settings, for example. But all of this is backed by the Secure Enclave. So that's file systems. And like I said, we don't know when HFS Plus will be deprecated. If you have a significant use of HFS Plus drives in your organization, it might be something to try to see if you can migrate those to APFS before we get to the point where Apple announces any deprecation there. And so speaking of long and significant transitions, let's talk about the transition to 64-bit apps. When we talk about this transition, I want to stress, consider this the roadmap for future transitions. It's perhaps the most complicated and nuanced one from a software point of view, at least from our point of view, right? And the transition timeline here is very long. And so we begin in 2003 when the Power Mac G5 was introduced. This brought the Mac into the 64-bit era, sort of a very lengthy transition. So a special build of Mac OS X Jaguar included 64-bit support for this new processor. A year later, we get an iMac with a 64-bit processor. Notably, no 64-bit portable Mac was ever shipped that was PowerPC based. So 2 years later, Mac OS X Tiger was released and adopted 64-bit processes for the OS. This is pretty quick for getting support for 64-bit stuff and moving off of 32-bit. But Mac OS X Tiger was also the first OS to ship with Intel support, so it had a lot of heavy lifting to do there. And this came with some limited support for 64-bit applications in advance of Mac OS X Leopard, which was announced actually just 2 months after Mac OS X Tiger came out, but didn't ship until 2007. So this release migrated Cocoa APIs for developers to 64-bit, so developers can go create full 64-bit apps. This transition was really pretty invisible to most normal users, not us necessarily, because of universal binaries. Download sizes inflated for a while, but not a huge deal, as long as developers were adamant and quick about updating their apps and getting ahead of it and not leaving it until the point of getting some user notifications. So as a side note, Mac OS X Leopard is one of the earliest examples of Apple's pursuit of an annual update cycle, and we see that today. All right, we get a new OS every WC. And despite its ambitions, obviously Apple missed a lot of deadlines and shipped this in 2007, mostly due to a certain product that they were working on at the time. So Mac OS X Snow Leopard became the first version of Mac OS X to be announced at WC, shipped a few months later, bringing us back to this kind of modern upgrade cycle that we have. And this obviously was the release that some of us remember was announced as having no new features, but was in fact full of lots of features, including full 64-bit support. And so we'll see Mac OS X Snow Leopard again. It's the first Mac OS release since System 7 that doesn't support PowerPC processors, for example. And it's going to play a significant role in this 64-bit migration, just as it did in the Intel processor transition. So in 2011, Mac OS X Snow Leopard received its last security update, ending all 32-bit hardware support. So now everything is 64-bit hardware that's supported going forward, and we start to see the full deprecation of 32-bit hardware, not receiving updates, rather. Apple's obviously moving quickly at this time to move to 64-bit. And while OS X Lion was introduced in 2010 in a Back to the Mac event, kind of started the modern era of iPhone influencing Mac. Was also the kind of start of incredible growth for the Mac, as Apple benefited from the Intel processor transition around this time, the effect of the iPhone, and OS X Lion, like I said, released in 2011, dropped boot support for 32-bit processors, while 32-bit applications continued to be supported. This OS also brought us the App Store for the Mac, which would help play a key role in finishing the 32-bit migration. On the developer relations side of things, and so 2 years later, we actually get the first 64-bit iPhone introduced a decade after the first 64-bit Mac. This transition kind of happened to align in that way if there were developers with apps on both the Mac and the iPhone. 2013 would also see the introduction of iOS 7, adding 64-bit support for the iPhone side. And then 2 years later, many years after initial support for 64-bit apps, 32-bit apps removal was formalized with a requirement for App Store apps and developer documentation, communication, and the compiler. App Store apps must include 64-bit support. And so in 2017, macOS High Sierra is announced as the last release to run 32-bit apps without compromise, as described by Apple at WC. This is a phrase we'll see again with Apple, and you might wonder, what does that actually mean? And we see what that means in 2018 when macOS 10.13.4 is released, showed us what without compromise meant. Every time that, or the very first time you run 32-bit software on macOS High Sierra, the user is presented with a warning informing the user to contact the developer. At the same time, developers are made more aware that they need to move things to 64-bit, because the following year, macOS Mojave is going to warn when any software is run every time. So this is ramping up in frequency and intensity throughout the deprecation and the migration. And we'll talk more about how Apple ramps that up in the mid-cycle kind of release like we've seen here. But in this instance, it's one of the first good instances I can see of a trend where deprecation warnings come at a mid-cycle release, where we're now having somebody be warned every time, or the first time they launch a 32-bit app. And this is all in support of efforts for the next OS, obviously, with macOS Mojave pushing that forward and notifying users on every single run. So after all, a thing to keep in mind, Apple knows what it's announcing at WC and what work on the deprecation side needs to happen to enable whatever they're working on for the next OS. A year after this, we're now a full decade after complete 64-bit support, and macOS Catalina has announced dropping support for 32-bit software. One reason this migration might have needed to be completed might be Apple Silicon. I'm just guessing. That probably made Rosetta 2 a little easier, which will be announced a year later. And in 2021, macOS Mojave received its last security update, marking an end to software support or security update support rather, for 32-bit software. So again, 64-bit apps is the kind of template with how Apple handles deprecation of developer technologies, throwing up user notifications. Those affect us with support volume and support load, documentation, for example. And while there are sometimes controls to limit this behavior, they may or may not exist depending on what deprecation is happening, because part of the intent of this is to put pressure on developers to move off of deprecated technology. I'm told if you file feedback, it helps. So when we talk about device management today, we're all talking about MDM, and Mac admins mostly associate MDM with macOS, but it started on the iPhone. And we can actually go back a little earlier to find out kind of how we got here. And going back all the way to 1993, the origins of Apple device management has its roots when Apple released at ease for workgroups. So this was aimed at corporate customers, offering a unified tool for managing file shares, printers, settings, and it did one other thing. It supported the management of mobile devices at the time, like the Newton, launched the same year. And a lot of fundamentals behind device management as we know it today were present here. In fact, some of the profile-like options read the same. And a decade later, it's 2003, right? Mac OS X, still in the early years, and imaging is how we manage Macs. Using Deploy Studio, for example, released in 2003. Jamf had the Casper suite, obviously at the time, as an Apple-focused commercial offering. And then 1 year after the introduction of the iPhone, Apple released iPhone Configuration Utility, which brought us configuration profiles for device management. One type of profile offered the ability to install an internal enterprise application, so bringing us internal app stores. So 2008, kind of the beginning part of modern device management with the MDM, because in 2010, Apple published the first version of the MDM spec, which brought us over-the-air updates, or not over-the-air, but I'm sorry, over-the-air enrollment for management, along with basic management functionality. At the time, we can see a pretty clear path that Apple's on, kind of seeing the opportunity to leverage the iPhone's success in enterprise to help elevate the Mac, push, user choice programs at Fortune 500 companies. And we can also see, looking back now, that MDM quickly became a requirement, effectively, for managing Macs. So in 2010, they published that spec. A year later, we get management controls for software updates, along with a bunch of other security-centric controls, the base stuff that was needed for the initial enterprise push at the time. This same year, OS X Lion is released with support for configuration profiles, which is a core part of MDM. Interesting timing, right? A year later, Apple brings MDM to the Mac in OS X Mountain Lion, bringing us into a new era of device management for Macs. In that same year, device supervision is introduced for corporate and institutionally owned devices, providing more management options for these. This would prove to be a pretty fundamental requirement for management of Macs in the enterprise. So the following year, Apple launched Apple Deployment Programs, featuring volume purchasing program for apps, for education, to allow distributing App Store apps, obviously. So not everything, but good for iOS especially. A year later, Apple expanded this with the device enrollment program for devices. So today we know this is automated device enrollment. Originally it was just for education customers. Another clear signal that there's a lot more involved with managing Macs at this point, and imaging was dead or soon would be dead. A year later, device-based volume purchase program comes out, so we don't have to require an Apple ID to install software anymore. This helps set the stage for more automated deployments, new types of deployments, in education, for example, with labs with multiple users. And then in 2016, the MDM spec adds a lot of MDM commands for restarting the device, and MDM really starts to seem like a requirement. It can be used for MDM-controlled account creation as part of enrollment, and this is almost a decade ago, and this is how far we've come since then. So on the heels of VPP and DEP, Apple launched ASM, Apple School Manager, a one-stop kind of portal for managing these things for education. Also, as part of ASM, Apple introduced the Apple Classroom app, expanding the functionality and feature set for ASM for education again. There's a big focus on doing this in education first. Because at the same time, you might know we talk about managed Apple IDs a lot today, but they started in education in 2016 and originally released to allow for shared access for shared devices, managed applications early on. So in 2017, Apple Configurator gets the ability to add physically connected devices to your device enrollment program, another sign you want to put things into that device enrollment program and move to that kind of enrollment and setup. The zero-touch kind of setup for your setup assistant. So this means we can get devices that are outside of those normal channels into that as a preferred way to go. The Mac gains support for Apple Classroom, which originally was iPad only. 2017 was a pretty busy year also because macOS got support for AirPrint, as well as user-approved kernel extensions. This kind of marks the start of Apple's focus on transparency in the context of management. So in a lot of cases, stuff like this is a trade-off for ease of use for us in favor of transparency for the user, kind of again going back to those priorities that Apple has. And this starts with user-approved kernel extensions. It also includes user-enrolled or user-approved MDM enrollment. So after that busy year, Apple debuts Apple Business Manager for the enterprise market, Apple School Manager branded for business, basically. This brings us to feature parity to the offerings in education. And then in 2019, we can kind of see where Apple might be putting a new focus on some of those, or a reason Apple was putting focus on some of the management transparency stuff with more focus on user-driven enrollments, as well as federated managed Apple ID. This is the first of one of many gaps Apple would close with managed Apple ID. Obviously, there are still some that we all have. But remember earlier I mentioned the Bootstrap token had more uses outside of File Vault. So in macOS 11 in 2020, Bootstrap token can also be used in a lot of contexts related to MDM. So if available, it can be used to authorize the installation of kernel extensions, software updates, all coming from MDM. These things help kind of improve our lives a bit. It's clear we have advocates within Apple working towards making some of these things easier for us. 2022, macOS Monterey brought the first set of new functionality kind of enabled by managed Apple ID, some data separation on macOS, just like on iOS. Corporate data can be separate. This is something that we haven't seen a lot of movement on, obviously. And a decade into the introduction, or after the introduction of MDM rather, Apple introduced us to declarative device management. And so declarative management is kind of a complete shift in how we approach managing Apple devices, right? A device can audit itself and correct what it's supposed to have without depending on an MDM server to check in with. There's 4 different types of declarations available for configuration, assets, activations, and management, as well as status channels. It's really a rethinking of modern device management. And at the time Apple introduced this, they warned that new functionality might only be available via DDM, not MDM going forward. So nearly a decade after the introduction of the Apple Watch, we get watchOS MDM support. I would take a guess, not a lot of usage of that in the room yet, but it's interesting to see it has been added about a decade after. A year after its introduction, declarative device management, we get the first wave of new management functionality that's only available via device declarations. So an improvement for automated device enrollment to require a minimum OS version, declarative software updates, and managed services like SSH. You can only manage these through declarative device management, and so if your vendor doesn't support this, you can't use these new features yet. The following year, this year, we saw the second wave of this. And so there are even more things that are nice new management features for us, but you may be dependent on your MDM vendor's support for. More improvements to declarative software updates, managed beta updates, managed Safari extensions, additional services configuration, including deploying binaries to a protected space on the disk. So a lot more compelling management functionality, but requiring MDM vendor support. And then also this year, in contrast to watchOS, really, visionOS added MDM support almost immediately after its introduction. And then after, like I said, multiple improvements in 2022, 2023, we get more improvements on managed Apple ID, or managed Apple account now, with domain capture, allowing you to verify your organization's domain and prevent new non-managed Apple IDs or Apple accounts from being created. That's something that a lot of us were waiting for, and it is going to help ease that transition. We also got Apple ID transfer. And so if you're not moving in the direction Apple is with managing your Macs, your job is going to be harder. We've seen this with MDM. We're going to see this again with DDM and some vendor support, depending on if that speeds up. And if you've been holding off on pushing the button on managed Apple accounts, for example, turns out that might have been good to hold off for a bit, because now you can capture that domain and kind of sort that problem out in different ways. You can at least kind of prevent more Apple accounts from being created. But pay attention to where Apple's going and the direction things are moving. It'll help you in the future. So let's talk about security. We know the iPhone had a big impact on the Mac and enterprise. And we can thank a lot of security on the Mac to the iPhone as well. So features like Gatekeeper were starting to be introduced early on in the iPhone OS era, bringing a lot of modern security features and functionality. So one interesting thing, though, we can start back in 1992 with Keychain's origins as PowerTalk in System 7. So this was a predecessor in a sense to Keychain. PowerTalk was a mail engine providing client-side interface to email. The Keychain concept was used in PowerTalk to manage login credentials for email systems at the time. Passwords needed to be retrievable easily, but also accessible in a simple interface. That might sound familiar if you noticed the Passwords app this year at WC. So in 1999, Keychain comes to the Mac as a standalone system feature. And then in 2007, on a different kind of topic of security, we start to see modern security stuff that we know on the Mac. So file quarantine is introduced in macOS 10 Leopard. And so if you've ever wondered about the extended attribute for quarantine flag from a downloaded file, for example, you can trace its roots back here to 2007. This was improved quickly when XProtect was introduced at its most basic at the time. XProtect maintained a block list of known malware and a bunch of, at the time, simplistic checks to prevent its distribution. Updates to XProtect actually continue today, include support for as far back as macOS 10.11, which I think a lot of people don't really realize. It's, you're not getting security updates on OSs that old, but you are getting XProtect updates still. If you have any old devices, that's nice. So in 2012, we enter the modern era of Mac security with Gatekeeper's introduction in macOS 10, Mountain Lion, and in Lion. In a kind of surprise move, Apple backported Gatekeeper to Lion as a mid-cycle OS update. And this kind of telegraphed the importance of Gatekeeper and security updates in general at the time, which again, that was kind of unexpected on their part. About a decade after its introduction, Keychain gets its most significant improvement to date with iCloud Keychain, 2013. And in 2015, so almost a decade now, system integrity protection was introduced, protecting certain system processes, files, and folders. This represented perhaps the most significant improvement to how the Mac works on the security side, but also a blocker for older management options like imaging. It's suddenly not very feasible at this point with system integrity protection. In 2016, Apple made a very important change to Gatekeeper in hiding the Anywhere option in system preferences for users. This kind of gives us a de facto standard that all software running on macOS must be signed, coming from the App Store or a known identified developer. Obviously, you can still go and toggle that Anywhere option, but it's clear that code signing is going to be important to the Mac's future. Also in 2016, the WebAuthn standard is published, which is a standard that brings us kind of the modern security key spec, moving us towards a passwordless future. This is around the time when the importance of identity in the work of a Mac admin kind of starts to show up, with managed Apple IDs as well. And then it feels like yesterday, but 2017 brought us the expansion of the Transparency, Consent, and Control Framework, or PPPC, Privacy Preferences Policy Control. And this introduced user approval of requests for accessing user data. So if you want to, as a developer, access somebody's calendar, photos, camera, and microphone are great examples of that. User has to allow that. In some cases, such as the camera and microphone, we all know access cannot be granted in a profile, can't be scripted, can only be denied. And this is that start of this kind of era of Apple putting a focus on user privacy. A year later, we get an expansion of that with user data protections, with the screen recording permission being added to this. Just like camera and microphone, can't provide access through a profile, can't provide access through a scripted solution. However, we do have the option of allowing standard users to allow approved apps that need that permission. 2018 brought us app notarization for the Mac. Perhaps an unsurprising move at this point. Apple said very clearly at WC that year that it would be important to the future of the Mac. So important that the next year it became a requirement for apps to be distributed through the App Store. App notarization was required in macOS Catalina, so you have to notarize and sign your app with a developer ID. In 2020, Safari 14 introduced support for biometrics like Touch ID and Web ID for WebAuthn. So we're getting one step closer to pass keys. But before we get there, 2021, Keychain adds support for one-time passwords, with multi-authentication being a common practice in the industry. And in 2022, we got a replacement for the malware removal tool, which was introduced back in 2004, so I believe, but been around for a while. Or no, I'm sorry, XProtect Remediator in 2019. I was only around for 4 years. But XProtect Remediator was introduced, and unlike Gatekeeper's kind of basic functionality, it is going to do periodic background scans for specific malware and report those to the endpoint security events. In a similar move, macOS Ventura brought us an update to Gatekeeper to check the notarization of apps on every run. So continuous enforcement of app notarization. It's even more important than ever at that point. And in 2022, Apple announces passkeys as a replacement for passwords. Hope everybody has seen some stuff about passkeys here, but they're more secure, easier to use, in theory can't be phished, and provide a better user experience for good measure as well. A year later, we see the importance of passkeys going forward, with passkeys at work becoming an option for managed Apple ID with iCloud Keychain. So we're moving towards a passwordless feature there. But in the meantime, we do need the passwords app that got introduced in macOS Sequoia. So while I think we can all agree Apple's focus on security is good and correct, sometimes it is at odds with our workflows and how things have been managed in the past. As Apple introduces more security features, it's generally best to embrace and adopt them rather than try to work against them, because odds are it's not going to change. Before we get into the next topic, I do want to preface this that there have been significant progress on improving software updates the last few years. I'm sure we've all seen this. There are many people within Apple advocating for these changes and helping get them through and helping improve software updates for everybody. But we can go back to 1999 to actually see where software update was introduced in macOS 9 before macOS 10. So this was introduced at the time as an early way to get internet updates for minor updates as part of the software update control panel. And then macOS 10 Puma brought improvements to software update, which had been ported from macOS 9 to macOS 10. These software update now uses XML catalog files, and more updates are being delivered through software update. I'm going to skip ahead though, because software update sat relatively untouched for years, seeing some improvements here and there. But in 2018, we got deferrals introduced in macOS High Sierra. Deferrals present an opportunity for you and your stakeholders to test updates during the beta period, defer those updates on a regular cadence or as needed for up to 90 days. It's something maybe some of us didn't adopt right away, but we would soon need to, because a year later, the introduction of macOS Catalina's deferrals kind of comes into light with anyone who remembers using things like Reposado to host your own software update catalog, to selectively allow or disallow specific updates in your catalog. That's deprecated in macOS Catalina. But Apple deprecates things from time to time. Surely it'll work for a couple of years, right? But the next year, macOS Big Sur removes that functionality entirely. So we are now using Apple's catalog for software updates for everything. If you wanted to hide an update, you would now need to use deferrals. You can hide stuff for up to 90 days. But you could still ignore updates, except that was also removed in Big Sur as well. So this is pushing us onto a clear path of deferring updates, not relying on just preventing updates entirely for macOS, which is obviously a good thing for security, but poses issues with Mac admins, depending on your deployments and your hardware support and all that. Also in Big Sur, we saw changes to how software updates could be installed because of volume ownership. So a lot of things moving here. And then in a mid-cycle update to Big Sur, we got distinct deferrals. So we got an improvement to deferrals where we can now make a different deferral for updates and upgrades as well as app improvements or app updates. So you can see that Apple's improving this, putting a lot of attention on making software update work better, but is not going back on that 90-day deferral. macOS Sonoma introduced significant changes and improvements to software update in the form of declarative software update, bringing us deadline-based controls for software updates to Apple platforms. And there's a lot of attention to software update in the enterprise context here. Also in 2023, CGTIL is deprecated in macOS Ventura. This ended up being replaced by managed Apple ID sign-in for software updates. This occurred during the beta cycle as another mid-cycle update to macOS. CGTIL had been around for a while, since at least 2016 or so, as a way to manage beta updates. Earlier this year, we got managed beta updates, kind of as a replacement for CGTIL in a lot of ways, for forcing users onto a beta track so you can build a beta testing program within your organization. So, of course, that doesn't seem like that could be all about software update, right? So let's kind of address the elephant in the room. Software updates can bring problems to us throughout the year. Over the last several years, we've actually seen this come in the form of the spring release, or maybe for our friends in the Southern Hemisphere, it's better to call it the mid-cycle update. And so these are updates that come out usually in the March timeframe, March or April, where Apple makes some significant change in how something works, and it creates a problem for a lot of us. So earlier I mentioned how back in 2018, we got one of the first examples of this trend, starting in macOS 10.13.4, running a 32-bit app displayed a one-time warning when running 32-bit apps. This came in advance of a more frequent warning that would come in the initial release of macOS Mojave. But then a year later in 2019, a mid-cycle update to macOS Mojave, 10.14.4 comes out and warns about running a 32-bit app every single time at every launch. So not once an app like it had been in High Sierra, not once per 30 days like it had been in the initial release of macOS Mojave, but every single time. This came right before the removal of 32-bit software support, and so this is Apple ratcheting up those notifications. Another year, another example, macOS Catalina 10.15.4, users begin receiving notifications about deprecated kernel programming interfaces, or KPIs, that are still in use by developers. This came right before the announcement of macOS Big Sur, where macOS would no longer load these kernel extensions by default. So you can kind of see that trend there already of Apple deprecating something, making sure it's known and about to be removed before the next OS is announced a couple months later. 2021, macOS Big Sur 11.3 brought us a good thing, actually, in this case, more deferral controls like I mentioned. So this is a great example of a beneficial mid-cycle update, kind of clearing the way for what's to come, because the next OS would come with a different major upgrade behavior, and so we would want those deferrals. 2022, we saw the removal of System Python. This one probably shouldn't have been a surprise, really. System Python had been deprecated since 2019, and Python 2.7 received its last update in 2020, so this one had been a long time coming. Obviously still created some problems for some software we maybe weren't expecting to have to contact vendors about. 2023, macOS Ventura 13.3 removed a legacy WebKit framework, and this impacted certain VPN vendors which were using that framework that had been deprecated for over a decade. This cemented a trend to me of, we'll continue to see this, where Apple deprecates technology or removes deprecated technology in advance of WC. They know what's coming in the next macOS release and it doesn't have that, and they're making a path to clear that through there. We saw that again this year with a slightly different scenario. The beta cycle for macOS Sonoma last summer introduced a deprecation notice for older frameworks that used stuff like CG DisplayStream is the developer framework for this, that is moving to Screen Capture Kit. This warning was removed prior to macOS 14.0 shipping and then reappeared in the spring beta releases for macOS 14.4. If you were active on the Mac and Min Slack, you probably saw that there were mountains of feedback that resulted in this change being removed before the final release of 14.4 shipped. This is just another good example of, if you're not testing the beta updates, you definitely want to. You really definitely want to in the spring, because there will probably be something significant that's breaking. And then if you're also not on the Mac Admin Slack, great place to join, and you'll hear about this stuff there as well. But what's next for next year? Well, we don't know what that's going to look like, but I'm very confident there will be some noise of a mid-cycle update to macOS Sequoia. I've made this claim in the Mac Admin Slack before. I think it's a very clear trend, and I think we'll see more of this. So as those continue to happen, help yourself again by being early to testing the betas, especially in that spring time period. But to that point, I filed feedback earlier today, actually, calling these mid-cycle updates out as good examples, asking from Apple management controls where possible, and then a longer beta cycle for these types of releases. Obviously, if something gets removed in the initial release at WC, we have all summer, maybe 8 betas to get an idea of where things are going. We still have 90 days for a deferral then at that point too. And it's a major OS upgrade. We kind of expect things to be broken, but if we could have a longer beta cycle on the spring release, I think we would all benefit from that. So now for the big one, which this gets into some more speculative territory, but has a lot more history behind it. As you might have guessed, hardware architecture, CPU transitions. Apple has been working towards the current transition to Apple Silicon for decades. And they've also done this before. So we're going to start with the PowerPC to Intel transition. Back in 1984, with the original Macintosh, was based on the Motorola 6800 architecture. Later on, as the platform matured, Apple evaluated several alternatives, eventually switching to PowerPC, which was co-developed with IBM and Motorola. And the origins of the PowerPC to Intel transition actually began in 1991 when System 7 was introduced, because System 7 would be the first OS to support PowerPC. Introduced a lot of things that are still around to this day: AppleScript, TrueType fonts, the menu bar clock, actually, and the Stickies app. A year later, initial efforts to move to Intel actually start as a research project. Intel had been considered for the Macintosh as early as 1985. But in 1992, this is Apple's first genuine, real attempt to move to Intel, which was dubbed the Star Trek project. With a short deadline, the team had to have a functional demo ready by the end of the year. They were able to do that, but the timing proved to be unfortunate. John Scully, who was kind of the push behind this, was forced out of Apple, and the enthusiasm for an Intel transition just kind of evaporated. But you might be thinking, wait a minute, 1992 is before PowerPC support even existed, and you're right. 1994 saw the introduction of the Power Macintosh, followed closely by the 1995 introduction of the Macintosh LC with PowerPC chip. Well, it would take a longer time and some more long-term vision. PowerPC was kind of always destined to be a short era. So a year later, like I said, PowerPC takes over the entire, at the time, large Mac lineup with the Macintosh Performa. And then after the 1997 acquisition of Next, work to transform Next Step into macOS 10 begins. Early on in this development cycle, an Intel version is available. Steve Jobs actually demos it to Dell in an attempt to license it. Interesting alternate reality that didn't happen. And while the original iMac has nothing to do with the processor transition, I do think it's important to talk about one of the amazing things Apple did with the iMac in the OS 10 era at the beginning there. Apple made the Mac as standard as possible, all in ways that helped Apple. Again, Apple's first priority is itself. They dropped proprietary connectors like SCSI, Mac Serial, ADB, replaced it all with USB. During this era, Apple went through a period of making hardware compatibility a priority, which really enabled the Intel transition to be as smooth as it did. Apple would repeat some of this to a degree with moving everything to Thunderbolt and USB-C. So eventually, Apple had to ship macOS 10, and the Intel variant was never finished. A decade after the initial work to transition the Mac to Intel, a new effort begins in 2002. Similar to 1997's demo to Dell, Apple demoed a version of Intel macOS 10 on a Sony Vaio around this time. And what began in 2002 became the version of Intel macOS support that happened, but it was all from an effort to maintain Intel-compatible builds of macOS 10 in advance of a full transition. And that transition started in 2005, about a decade after introducing PowerPC Macs. Apple announced the transition to Intel. To help ease the transition, Apple introduces universal binaries and Rosetta. And as it turns out, The Intel era's days are already kind of numbered before it begins as well, because around this same time, Apple starts Project Purple, the project to develop iPhone. And while there's competing software projects in play, ultimately the project to bring macOS 10 to iPhone 1. And of course, Intel didn't have a chip that would go into an iPhone. And so Apple kind of had already started, doing some of the work towards the Apple Silicon transition in 2005. So the Intel transition proved to be very quick, taking just a year after its announcement. And then you might remember earlier, macOS 10 Leopard added support for 64-bit apps. It was the final version to support booting from PowerPC, so that's a very quick 2-year transition there. And with the release of macOS 10 Snow Leopard, Apple dropped boot support for PowerPC and in the era of support for PowerPC hardware. So again, very quick. We probably won't see that quite as quick with Apple Silicon, but something to keep in mind. 2 years after dropping boot support, Apple discontinued Rosetta, ending that software era for PowerPC software. And then 2 years after that, hope it's clear there's a 2-year trend here, all PowerPC Macs become obsolete. So they've reached that point where they're not going to receive any updates of any kind. But a few minutes ago, I mentioned in 2005, marking the development of iPhone and being announced at Macworld in January 2007, iPhone runs OS 10. But we can actually go back even further than that, because back in 1985, Apple invested in a company called Acorn Computers, which created ARM. Acorn's ARM architecture was first spotted by Apple's Advanced Technology Group, who felt it might become the basis for a future portable device. Soon after, partnership was established and work began on a chip for a tablet computer. And in 1993, we get that tablet computer with the Newton, the first Apple product with an ARM processor. The Newton platform included its first product in the lineup, the Newton message pad. And then a couple years later, we had another product in the Newton lineup, which was introduced as the eMate, an education market device featuring a curved laptop design, translucent case. It's one of the first products Johnny Ive designed, and its influence on the iMac and iBook were very clear in the years to come. But again, it has an ARM processor. While the Newton didn't quite pan out, though, another ARM-based Apple handheld did. 2001's iPod also featured an ARM processor. Nearly every iPod, except for the first generation iPod Shuffle, which had something different. As we all know, iPhone was introduced in 2007, had an immense impact on the Mac, and this is also not a surprise, ARM processor. And then following iPhone's introduction, 2010, the iPad, ARM processor. And then the iPhone 4 with an ARM SoC, which is the first in what we can now call the Apple Silicon family. So in 2010, Apple introduces the iPhone 4 with the A4 SoC, made it into multiple different products that year, as well as, in addition to an iPhone, it's updated iPod Touch and an Apple TV, replacing the original Intel version from 2007. And in 2012, we get a surprise product getting Apple Silicon, the Lightning Digital AV adapter. So there's actually a little ARM-based microcontroller inside of the Lightning Digital AV adapter. The software company Panic tore one down and opened one up to kind of discover this after noticing some weird artifacting when they were using it. And just another example of using ARM, and obviously there wasn't anything from Intel to go in there. Apple Watch obviously also features an ARM system, the S1 system in package. 2017, Apple introduces the HomePod, also with an ARM SoC. But how did we get to this point? Well, 2008, Apple acquired PA Semi, bringing silicon engineering in-house for the first time. And just 2 years later, they brought us that first SoC designed in-house by Apple, like I mentioned, the A4. Kind of, again, marked the start of a decade of work to move Apple to its own silicon. At the time, it was maybe hard to see the writing on the wall, but 2017, we got the second generation iPad Pro, and this actually matched the performance of Intel model Macs at this time, kind of making it very clear this transition was going to happen. And this processor actually is what wound up being in the developer transition kit for the Apple Silicon transition. So also in 2017, Apple added the T2 chip, which we talked about earlier, runs BridgeOS and SepOS for the secure enclave processor. While this was labeled a security chip, it's really the first part of Apple Silicon in Macs, and handled a lot of operations that were not going to be handled by the Intel processor. And it's just a lot of Apple Silicon going on in 2017. So after matching performance, Apple announced what might wind up being the final architecture transition of the Mac, Apple Silicon. Similar language to the Intel transition was used. There's Universal 2 binaries, there's Rosetta 2 to help ease that transition. And obviously the Intel transition would inform the playbook for this one. And so to get developers started, like I said, there was an A12X based developer transition kit available. That was at the time a 2-year-old processor. And just months later, Apple started transitioning and introduced Macs with Apple Silicon, with the M1 and Mac Mini, MacBook Air, and MacBook Pro. A little bit of a different move from Intel. These Macs had the same industrial design that we're used to as their Intel-based predecessors, putting a focus on the performance and efficiency gains of Apple Silicon over Intel. Next year, Apple introduced the first Mac with a new industrial design informed by Apple Silicon, the M1-based iMac. That brand new design was really not something that would have been possible with an Intel chip inside of it, and set the stage for future updates to Mac hardware later that year, which brought us the M1 Pro and M1 Pro Max alongside brand new 14-inch and 16-inch MacBooks that probably most of this room is using. And then early in 2022, Apple introduced a brand new desktop Mac for the first time in years in the form of the Mac Studio with the M1 Ultra, so a fourth member of the M1 family of chips. At the time, Apple also confirmed the development of a Mac Pro with Apple Silicon. Later that year, kind of perhaps setting a new cadence at the time, Apple released an M2 alongside a redesigned MacBook Air. And then early in 2023, Apple released the Pro and Max variants of the M2. Pretty clear pattern, you might think at this point, of how it's going to roll out Apple Silicon. And then a little bit later in the year at WC, the M2 Ultra in the new Mac Pro. The transition is complete. And then in a surprise move in late 2023, Apple released the M3 and M3 Pro and M3 Max all in one event. So up until now, like I said, we thought we might have had a pattern with how Apple was going to launch these. Maybe we're starting to see that might not be the case. Perhaps more surprisingly, just a few months ago, Apple released the M4 in an iPad. And so obviously there's not a clear pattern for Apple Silicon yet, aside from an annual release cadence of some kind. In many ways, Apple is a company that favors an annual cadence, and we see this from products to their Apple Silicon as well. And also this year, obviously, we got macOS Sequoia. And in the context of the Intel, now Apple Silicon transition, one of the things that Apple did with the Intel transition was kind of keep features from PowerPC Macs because of performance limitations. We're seeing that again with this transition. Every new Apple Intelligence feature, for example, requires a Mac with Apple Silicon, and then there are some non-AI features that also won't work on an Intel-based Mac. So time might be limited on some of those. So this is the only section where I'm getting into the future. In 2028, Intel-based Macs are going to reach vintage status. We know Apple classifies vintage and obsolete, for example. And so in the Intel transition, PowerPC-based Macs saw their last OS release 4 years prior to this date. As we know from WC, this year wasn't the year, but we're getting kind of uncomfortably close to the last release that supports Intel. And in 2030, the last Intel-based Macs will reach obsolete status. Again, using the Intel transition as an indicator, Rosetta was removed 4 years prior to this date. It's entirely possible, and I would say pretty likely, Rosetta 2 is going to have a longer lifespan, but you don't want to be relying on it at this point. We're getting close to the point where it might wind up being the end of that time. So Apple's taken a more conservative approach with this transition, of course, but we don't know when any of these things are going to happen quite yet. So we know those dates. What do I think will happen, just speculatively? I think next year we will probably see the lack of Intel support with new OSs. We'll continue to see Rosetta 2 for probably longer than we had with Rosetta, like I said. But it's obviously an important thing to keep aware of. And if you have any Intel Macs, you probably want to consider how long you're going to be able to support them. Because we don't know when Apple is going to discontinue Rosetta 2. If you have a security agent or a VPN or something else that requires Rosetta 2, still today, that's something you want to press your vendors on. And if you have Intel-based Macs, you want to replace those before it gets too late, because at the end of the day, we don't know, but we can use these timelines as an idea of where Apple is going. And so just as important as it is talking about these transitions, it's important to know what technology Apple has deprecated. So just real quick, I've got a slide with a list of everything that I could find that is deprecated that might be relevant to Mac admins. So this isn't a comprehensive list, but there are plenty of things that are deprecated and might not wind up affecting you. But deprecated technology does go away, and you want to be on top of that. One of the most impactful things on this list is related to screen capture and screen recording, which became an issue in macOS Sonoma beta cycle last year, like I mentioned. It's also continuing in the Sequoia cycle. So if you have screen sharing apps that are throwing up that prompt that tells you as a warning to the user, you might want to contact those vendors. They probably already know, but put some pressure on them. And as one specific example, Apple does, despite what we might think sometimes, tell us exactly what's happening. So the audit subsystem was deprecated in macOS 11, disabled since macOS 14, and this is Apple putting it in all caps, will be removed in a future version of macOS. So if you have anything using that, you'll want to put some pressure on those vendors or internal teams that are using any of that. So just to kind of recap real quick, everything we talked about, and file systems and the pretty slow pace that Apple deprecates them, 64-bit apps and how those user-facing notifications are the template for developer-dependent deprecations and changes. Device management and how declarations are the future of management. User privacy and transparency is not changing. Security and how it'll continue to change our workflows, software update, and the clear trend of those mid-cycle updates like I mentioned. And hardware architecture and how long, or maybe not, that we can expect Intel support and Rosetta 2 to continue. So again, this is all just the importance of knowing what deprecated technology might affect you, and Intel is obviously the biggest one for a lot of us at this point. So we do have a little bit of time for Q&A. If anybody has any questions, I'm happy to answer stuff now, out in the hallway, out in the rain, as it sounds like it's raining. Also on the Mac Admin Slack as well. So.
Was the Star Trek project Marklar, or was Marklar Star Trek?
That's a good question. You asked if the Star Trek project was Marklar, right?
Yes.
I don't know offhand. I think it was a separate project that started because it was an earlier, like short-lived transition as far as or experiment as far as I saw. But yeah, definitely lots of fun history in the transitions that did or did not happen, and how Apple got to stuff that. There is a references page that'll be available in this copy of the slides that are going to be available on the Mac Admin's website as well, which has some of those stories. Yeah?
I was surprised you didn't make any references to hardware licensing that took place back in the 90s.
That's, yeah, so for the recording, I guess, you mentioned hardware licensing. That's a good point, and yeah, that's a big thing that we don't think about much anymore, right? Because it was a very short-lived era in hindsight.
Yeah, Apple was making shit, well, what's a license to Apple?
Yeah.
License versus build.
Right. Well, and they, like I said, tried to license to Dell and stuff, but they did license it to lots of companies. So, yeah. If there is any feedback you guys have, I'd love to hear it. First time presenting, obviously, and I know it's helpful for the conference as well. And yeah, thank you guys.